Hey kids, Flexing Teacher Weber here. Hope you're having a good day. Why do I call myself Flexing Teacher Weber? Well, whenever I meet people or whenever I greet people, I always flex for them. And it's supposed to be sort of a joke because I'm not the most muscular guy around. So I hope people get the joke that I'm not flexing because I think I'm tough. I'm flexing because I think it's sort of funny that a guy who's not the biggest muscle guy always flexes all the time. That's why I call myself Flexing Teacher Weber. Now, from time to time, I'm going to be doing videos this year that review the work we've done in class. So if you've had difficulty understanding in class, you can check out the video and hopefully that will help you understand. And I'll post these to my YouTube channel, Flexing Teacher Weber. I'll also email them to your parents. So we started out the year looking at divisibility rules, and in grade 7, we really try to connect the divisibility rules to fraction concepts. The divisibility rules are something you have done before, but we're going to really work hard to connect them to fraction concepts. So the first rule I want to look at, or before we even look at divisibility rules, is just talk about what divisibility means. A number is divisible by another number if they divide with no remainder. So for example, 8 is divisible by 2 because 8 divided by 2 equals 4. And there's no remainder. However, 8 is not divisible by 5 because 8 divided by 5 equals 1 and there's a remainder of 3. So we say 8 is not divisible by 5. Now, we can use different rules that have been developed to determine divisibility. We're going to look at these rules in groups, and I'll probably have to do 2 videos to get them all in. So the first rules, I try to group them all together because there's certain ones that have similar traits. The first group of rules, you look at the last digit of each number to determine divisibility. Except for 1, the divisibility rule for 1, the divisibility rule for 1 is that all numbers are divisible by 1, right? So anything can divide by 1. 350 divided by 1 is 350. 400 divided by 1 is 400. So all numbers can be divisible by 1. Now, the divisibility rule for 2, if the last digit is even, which means it ends in 0, 2, 4, 6, or 8, then it is divisible by 2. And I have some examples here. And these are ones we did in class. So 25,628, you would focus on the last digit, the 8. Since it's even, we would say yes. That number is divisible by 2. And all we're worried about right now is worrying about if they are divisible, not what the actual answer would be, the quotient. This one I already have circled. The 123, the last digit is an odd number, so we would say no. 123 is not divisible by 2. And then the final example, 12,450, you can see the final digit is underlined, it's a 0, and since that's an even number, we would say yes. That is divisible by 2. So divisibility by 2 is a very basic rule. Now let's look at the divisibility by 5 and 10. So they're very similar to the rule for 2. A number is divisible by 5 if the last digit is a 5 or a 0. So if we look at these examples, the last digit is a 5. So that number will be divisible by 5. We will say yes. And if we look at this example, 45,610, the last digit is a 0. So we say yes, it's divisible by 5. And then 513, the last digit is a 3. It's not a 0 or a 5, so we say no, that number is not divisible by 5. So again, the divisibility rule for 5 is similar to the divisibility rule for 2. And then same thing for 10. The rule for 10 is if a number ends in 0, it is divisible by 10. So 120 ends in a 0, that's a yes. That's divisible by 10. Whereas 785,055 ends in a 5. That number will be divisible by 5, but it will not be divisible by 10. It has to end in a 0. And 180,010 ends in a 0. So yes, that number is divisible by 10. So those are the divisibility rules for 1, 2, 5, and 10. In another video, I'm going to show you the divisibility rules for 4 and 8. So that's all for right now. Flexing Teacher Weber out.